Friends, very good morning. We were dealing with imidazole synthesis, which is given by Debus and Rad Zizweski. We now let us discuss the synthesis of metronidazole, an imidazole derivative. Metronidazole is like this. It has a basic ring system as imidazole. At the second position, the methyl group, and the fifth position, the nitro group, and the first position, an ethanol group is attached. Its IUPAC nomenclature is 2, 2-methyl, 5-nitro, imidazolyle, ethanol. How we can approach for its synthesis? Whenever any molecule is given to us, we break that molecule into smaller pieces intuitively such that we get a starting material. This is an approach called as retrosynthesis, meaning reverse of synthesis. Any molecule given to a chemist, he intuitively split the molecule such that he end up with the starting material, and that starting material and the reactant he reacts to get the final product. Here if I analyze the structure, this is an extra appendage fitted to the imidazole ring system that I can attach separately. I will take this CH2CH2OH group separately, a ethanol group. This imidazole ring system, this part if I break, it is a NCH2CH2N. This can act as one synthon, and CH3C is another synthon. And nitro group also I can attach. This is another synthon. Now, as I have got this is a 2 carbon and 2 nitrogen donor. I have to select a molecule which has this fragment NCH2 CHCHN. I can take diaminoethane. We have to select this reagent or the substrate such that it reacts with another reagent to get this imidazole ring system. This CH3C, it is a 2 carbon donor. I should select one 2 carbon donor such that that 2 carbon donor reacts with this diaminoethane to give imidazole ring system. That's why here I have selected methyl nitrile or acetone nitrile. Here, mono group, the nitrogen is electron rich center. I have to select a electron deficient center containing compound such that these two molecules react. This is lone pair of electrons, and this is the positive center because it is attached with an electron withdrawing group, nitrogen. This electron rich center forms the bond with carbon, and once it forms the bond with carbon, it becomes pentavalent, which is unstable. Carbon has the capacity to bond with only 4 atoms. Already 3 bonds over here and 4th bond over here is already there. 5th bond is formed. It becomes unstable. And it has the tendency to maintain its stability. That's why pi electrons get shifted towards nitrogen, and nitrogen has to maintain its trivalency for its stability. That's why N minus, it combines with H plus from the reaction medium and it gives NH. over here. The bond has been formed between carbon and nitrogen, and C triple bond N has got converted into C double bond NH. Then again, there is lone pair of electrons on the adjacent nitrogen, and this is again the positive center because of the presence of this nitrogen, and here also another nitrogen. It's highly positive center because it pulls the electrons towards nitrogen. This also pulls electrons owing to its electronegativity, renders this carbon electron deficient. This is an electron deficient carbon and this is electron rich nitrogen. Again, these electrons can attack on this positive center and it has to maintain its tetravalency. Pi electrons shift towards nitrogen and this combines with H plus from the reaction medium and gets converted into NH2. I have got imidazoline derivative. If I aromatize it, I get imidazole ring. The nitrogen and hydrogen bond breaks and thus electrons shift towards this, forms a carbon and forms a double bond and amino group gets kicked off. And this NH2 minus and H plus combine together to lose as ammonia. And I will get a compound imidazole with a double bond between carbon and nitrogen and loss of amino group. I will reduce this by using zinc. The carbon-carbon bond, it becomes, hydrogen gets removed and it becomes imidazole. I have prepared 2-methyl imidazole. I have to add nitro group and attach ethanol group to this to get metronidazole. How can I introduce nitro group? By nitration. I use nitrating mixture, nitric acid and phosphorus pentoxide, and NO2 plus reacts with the fifth position of the nitro of the imidazole ring and I will get corresponding 2-methyl 5-nitroimidazole. If I add ethanol, I will get corresponding metronidazole. I take chloroethanol, nitrogen here is electron rich and this is the positive center owing to the electronegativity of the halogen. It attacks on the positive center, a bond is formed and chlorine acid is an easy leaving group, it gets kicked off. The Cl minus and the H plus, they combine together to lose as HCl and ethanol group getting attached to nitrogen of the imidazole ring. I have got metronidazole. This is the process of synthesis of metronidazole. Metronidazole finds its use as an antibacterial agent. It is used to treat infections in different areas of the body. It also finds its use as an antiprotozoal agent in the treatment of trichomoniasis and amoebiasis. Extended release dosage forms are available for the treatment of vaginal infection of women, which is called as bacterial vaginosis. This is the approach we can follow for the preparation of or synthesis of metronidazole. Next class, we can deal with other drug molecules containing imidazole ring system. Till then, have a nice day. Thank you.